Anybody still hear me? Thank you. I want to thank Walkiria before I get started for putting on a wonderful symposium and giving us the opportunity to speak. My name is Yash Sabharwal. I'm co-founder of a startup software company based in Austin, Texas. We have developed some interesting tools for knowledge management, and I'm going to talk about that today. Our keynote speaker, Lena, posed an interesting question where she mentioned during her talk that a lot of organizations are struggling with how to manage all the knowledge that they're developing and the process development activities of their programs. So this talk is going to focus on some of the ideas that we have developed that we think are going to help solve that problem. So I'll start with the Pharma 4.0 discussion. This is a topic that has been discussed already here today. It is of interest in many conversations around the table. This diagram comes from a paper that was published, or an article that was published in Pharmaceutical Engineering back in 2017. It sort of tries to encapsulate the idea of what Pharma 4.0 is for the pharmaceutical industry. And our focus is on the knowledge management and quality risk management piece, because in our opinion, it's going to be very difficult to go from the enablers to the elements, which is sort of that vertical transition, and then horizontally going from control strategy to achieve that holistic production control strategy without that bridge being very strong. And that's where there's a lot of, in our opinion, a lot of challenges. People can do the work on the enabling side, they can do the work above, but if there's no bridge between those two sets of activities, that lack of communication and breakdown in communication makes it very challenging to really enable Pharma 4.0 in the way that it needs to be enabled. So we take that diagram and we sort of summarized it or condensed it in the idea that you take best practices, which are things like quality by design, data integrity by design, the ideas of collaboration and automation, data and analytics, and you try to enable knowledge management in a way that's more functional, working with data-driven process development, creating robust understanding, and ultimately getting products to patients faster. So how do we do this? That's always the big question. There's a lot of, we need to do this, but it sort of falls short a lot of times in the conversation in terms of how do we do this. So I wanted to propose a thought experiment where we say, well, let's start with the idea that the focus of your knowledge management is really requirements management. That's where it all starts, right? Whether it's patient requirements, product requirements, process requirements, you're always focusing on requirements. And so that's where you should start with the knowledge management. Then you can bolt on these other pieces of risk management, data management, testing and analytics, and ultimately connectivity to devices where you're bringing in data from a continuous manufacturing perspective. And it's interesting that the ISPE has taken the lead on the idea of Pharma 4.0, but we're now seeing the FDA talking about this idea of CASA, which is knowledge-aided structured management. And they just actually published an article, Lawrence Yu and Larissa Wu from the Office of Pharmaceutical Quality at CDER just put out an article in the International Journal of Pharmaceutics talking about how the FDA is thinking about restructuring the way they take information from the industry and to improve their ability to review the information that's coming to them. So instead of trying to sort through thousands of pages in submissions, can you create a structured application process where you're essentially feeding them what are your requirements, what are your acceptance criteria, what are the risks around those. That approach follows a development workflow much better than the document dump that you do through an ECTD approach, where information is categorized by type of information, but not necessarily how that information was developed. It certainly facilitates the assessment of risk for them, and they feel that they could be more objective about how they review these submissions as opposed to being more subjective right now. What does knowledge management look like today? I say that there's a lot of QbD in knowledge management today, but it's not the kind of QbD we want. It's quality by documentation instead of quality by design. And you have a heavy reliance on Microsoft Office and electronic quality management systems that then lead to quality by documentation. These software solutions are poorly integrated. So how many people here use Microsoft Excel and Word and PowerPoint and Visio on a daily basis to manage their knowledge in process development? It's a lot, right? Those tools were developed in the 1980s. And we're still using those today. Those are reporting tools. They're not really knowledge management tools. So there's poor integration, heavy reliance on Microsoft Office. As a result, you have a poor visualization of your process and risks. We focus a lot on two-dimensional tables. Well, if you have multi-dimensional data sets, two-dimensional tables don't help you very much. And so as a result, we end up with poor process understanding and a lot of products that end up underdeveloped by the time they're submitted to the FDA or any other regulatory agency for approval. Why do these problems exist? So we'll start with the idea of unstructured versus structured data. A lot of information is stored these days in documents. If you think of a document is a unstructured repository of data. Some documents have only requirements in them. Some have requirements and some risk information. Some have only risk information. Some have data and requirements. So there's no structure to this information. It just sits in documents. And if you're looking at trying to understand what's going on, you have to usually sort through multiple reports to figure out what's happening. A lot of time is wasted. There's no way to link the information. You can link documents, but you can't mine the data very easily from the document, so it doesn't do very much good. So what if we structured the data? What if we said, well, we won't track documents anymore, we'll track requirements. You can build a database of requirements. You can then have data and risk information as subsets of the requirements attached to those. Documents then become supporting information, not the primary information. And then you can take records, because these are now databases, these are elements in your database, you can link these. You can link this information now in a way that you can't do with documents. What will this mean for risk assessment, traceability, and visibility? So this is my favorite slide in the presentation. That spreadsheet was a spreadsheet that I was using 5 years ago when I was Chief Operating Officer at Xeris Pharmaceuticals. And I was trying to figure out how to manage our process development and scale-up activities. At that time, I went to all the various consultants we were using, and I said, what are the tools that people are using out there to manage knowledge? And they said, Microsoft Excel, Microsoft Office, PowerPoint, so on and so forth. Which was kind of absurd, but I couldn't do anything about it, so I had to do what everybody else did. And so my spreadsheet had tabs for each of the unit operations and different categories of materials. This was just one unit operation where we were mapping, properties of the bulk, quality attributes of the bulk of that unit operation to final quality attributes. And so you have a lot of numbers and colors. You sit down around a table, everybody has their input as to what risk level they think things are. There's no place really to put justifications or any supporting information around these numbers. You hope that all these same people are at the next meeting, so you're not trying to figure out why this was a 10 and that was a 5 and so on and so forth. So the amount of time that was wasted using something like this was incredible. And then you have the fishbone. I think both of these tools are absolute garbage. You can't see anything in a fishbone beyond that one particular problem you've identified at the end. But we all know that pharmaceutical systems are nonlinear. These relationships are not like devices where they're linear engineering systems. There's a lot of nonlinearity. There's a lot of things that happen in unit operation 1 that may affect something in unit operation 6. It's very challenging to see these kinds of relationships with these tools. And I watched how some of those nonlinear relationships affected our ability at my last company to develop a well-controlled process. So what should we do? How do we change the way we think about our information and represent our information? Well, luckily, we're not the only ones dealing with this problem. Other industries have dealt with it, and you look at the likes of Google and other companies, they figured out that information is nonlinear, that things connect, there's many-to-one relationships and one-to-many relationships, and the better way to represent information is what they call the knowledge graph. That's what they've developed. That's what a lot of that search engine technology is built on the idea of a knowledge graph. Why? Why would this be better than what we do today? Well, the knowledge graph is tailored to how we perceive information. So as humans, if you think about it's called the Gestalt theory of visual perception. It comes from the Berlin School of Experimental Psychology. We don't process information in rows and columns of numbers, right? The way we perceive information is based on certain laws, one of which is the law of similarity. We recognize shapes that are similar. We recognize sizes that are similar. We recognize colors that are similar. You can extend that to other laws, proximity. So the idea of clustering information. That's how we can identify differences. Similarities, closure, being able to distinguish between a foreground and a background. That's why the knowledge graph works so well, because that's how we've evolved to understand information. We haven't evolved to understand information in two-dimensional tables. So what does this all mean? How do we bring it all together? We propose that you start with requirements again. Build your system of knowledge around requirements. Structure it with acceptance criteria, criticality assessments, process capability, and risk control. It's a progression. What feeds this information? The knowledge you have about how you've developed your product. Patient safety and efficacy. Patient safety feeds criticality. Manufacturing data and analytics feeds your understanding of process capability. Detectability and control strategy feeds your understanding of how you're going to control risk. This is not something you know all at once. You build this over time as you develop your process. And then you bring in your progressive risk assessment where you get your criticality evaluation, then you get your process risk, and you get your RPM. So you have a requirements-based structure for information, and then you built in what we call progressive risk assessment. So one of the things that was also very challenging for us with that spreadsheet model was everybody wanted to put all the numbers in right away. They wanted to put in their criticality, their occurrence risk, the detectability, but you don't know it all at once. So you really have to think in layers of risk and how you're going to address this over time, what you know in the beginning and what you know at the end. And so this is based on ISO 14971, effectively. You have a hazardous situation that causes harm. In the beginning, you say, well, what is the severity of the harm to the patient, and what's the likelihood of that harm? And then that's your criticality assessment. That doesn't change with better process. So from there, you go to your process risk, or what's the risk in ISO 14971, which then folds in those two parameters with occurrence. So what's the likelihood that you will be out of specification effectively? From there, you then bring in your detectability risk to get your risk priority number, and that's your overall risk. And again, the idea here is that you cannot reduce criticality with an improved process. But with data-driven understanding of your process risk and your ability to control that risk, you can actually reduce the overall risk even though your criticality is high. So the tools that you develop with your requirement structure should follow this flow. So we say, let's go nonlinear, right? Let's use the idea of the knowledge graph to get away from the spreadsheets and the fishbones, because all of that information can be combined in a much simpler representation of information. This is an example of a knowledge graph map that we can generate with our software. And in this particular example, we focused in on filtration time, which was a intermediate quality attribute defined in the system for a sterile filtration process. And if you have a knowledge graph where all the elements are requirements of some sort, you can think of, again, a Google Maps analogy where every requirement is like an address. When you use Google Maps, you type in an address and it zooms in on that location in the world. Well, you can do the same thing here. So we typed in filtration time and zoomed in on that requirement. Because all these links have been defined within the software, you can select an upstream filter that tells you what are all the inputs into that particular parameter that's of interest to you. You can select a downstream filter that tells you what does it affect downstream. So at the top layer, you have your target product profile requirements, which are the patient requirements, if you will. The next layer are your final quality attributes, and then you have clusters by unit operation. It's color-coded by risk. You can filter out high risks versus low risks. There's so much dimensionality that's evident in and can be represented in the knowledge graph that it simplifies all of this extra work that we do here on the right-hand side, the left-hand side, excuse me. And so the combination of it, so this idea of knowledge-gated structured assessment essentially enables quality by design, because you can start with the end in mind, you can actually link your patient, product, or process requirements in a way that's all that information is in one place. You don't have multiple tables, you don't have multiple reports, you don't have multiple fishbone diagrams trying to make sense of all that information together. Risk assessment becomes integral to the process, not a separate activity. It's more than just design of experiments. So many people, potential companies that we visit, say, well, we don't do, we hand the QbD stuff off to statisticians. That is an implicit, confirmation that they think that QbD is just DOE, and it's way more than that. It's way more than that. It's more holistic, and you can cycle through patient, product, process, risk assessment with a requirements-based structure. And of course, don't forget data integrity. If you are managing the requirements and not the documents, you can actually route requirements for approval through an electronic signature, which is a much tighter control over the information than the document itself. So let's go back to knowledge management. What does it look like in a requirements-based world? Well, you have a structured repository, so you can define your requirements and link them. You can integrate data and risk management. So now you have this integrated functionality, which helps with data integrity. You have much better visibility and transparency into your process. So again, when we visit companies and talk about our software, a lot of them tell us that their challenge is that they don't know what's going on in their process. They have data sets that are all over the place. Different groups have different information. They are challenged with making the kind of decisions that they need to make because they don't have all the information in one place. So by moving away from this spreadsheet, fishbone type of approach to the knowledge graph type of approach, you can give them the traceability they seek and get much better visualization of their complex manufacturing systems. And so we believe that going with this structure and this approach, you can get a much better understanding of your process and potentially achieve that holistic production control strategy that is the goal of Pharma 4.0. So that was the essence of our talk. Thank you. I also want to thank my colleagues, Kevin Schifrin and Luke Guerrero, who helped me put this presentation together. And I'll take your questions at this time.
Cool. Time for some questions. You also open the lab? You go first. No, you go.
Thank you. I've been working with a software which is called Mind Map and Mind Analytics. QbD is quite similar. You drive your thoughts based on, let's say, the spider of ideas. We encountered one problem, and this is that the file, after all, with all the attachments, is super big and super large and cannot be opened anywhere. This is the practicality which I wanted to ask you how to manage this.
So our software is built on Amazon Web Services, and so it is a database system that has effectively infinite capacity. And the approach we've taken, if you have a requirements-based structure, then you can say, well, we will just attach documents and other information, or just links for that matter, links to the appropriate documents or other information to that requirement record. So you don't necessarily have to store all that information. You can or not, you not have to worry about it. But we don't have those limitations because these are not files, for example. These are actually databases of information, and those databases are effectively, limitless in terms of how much information they can store. The other thing that's important to note is that if you're going to use any kind of tool for managing the knowledge of a full development program, ultimately it has to be compliant with the requirements of CFR Part 11 in the US or EU Annex 11 and be able to be validated. And so those are considerations that have been taken into account as well.
Thank you for a nice presentation. So the visualization of this holistic production and manufacturing control strategy, what would that look like? Because now I can see it's a link to all the different documents that points towards control strategy. So if you're going to make a change, what kind of view would you have?
Yeah, so we have, well, in our software, we allow you to create those links. The visualization around those, which we're developing right now, would be, an example would be a flow chart that says, well, here's my API, here's the material attributes, here's all the tests, right? And then you can have dashboards which tell you what's the criticality of the attributes, what state are those tests in, are they designed, qualified, validated? So as you link all this information together, you can now start to create very powerful dashboards to look at what's your manufacturing readiness, are there gaps in your system? We have considered actually having a scanning feature, kind of like a virus scanner that scans your computer for any problems. You can imagine scanning your system to say, hey, these 4 tests are not validated, and you're about to move into you want to kick off a manufacturing batch or whatever. Because all that information is linked, you can then find gaps where the links aren't. Did I answer your question?
Yeah, thank you.
Thanks again, Nash. You're around for lunch, so
I am.
by all
Sorry.
means,